Hello everyone, glad to see you on this conference. And today I'm presenting a paper now named Knowledge as Recollection, Advancing Multimodal Retrieval-Augmented Generation. It's done with an affiliation of Novosibirsk State University Laboratory of Applied Digital Technologies and Siberian Derunets. Firstly, start with the motivation. Humans always wanted to create an artificial imitation of themselves, and we can see it in literature and other sources. And one of the reasons to create multimodal solutions is to create an AI that can perceive the world in many aspects as we do. And other reasons of the evolution to create multimodal solutions is achievements in different specific tasks like language modeling with well-known transformers and big boom of decoder models to provide a lot of solutions, and also advances in different modalities that were also affected by transformers and other solutions, and even more flexible solutions, for example, like contrastive image language pre-training, which can result in solutions with one-shot or even zero-shot predictions. And we need to identify certain features of multimodality. First of all, information in different modalities can reflect different qualities of the objects, and modalities can be related and they can have intersection of their features. Also, modalities can create new information when they're used together. And there is crucial challenges in this area. They are basic, but they should be mentioned. First of all, multimodal data representation, how we can represent multimodal data, how can we compare the data between different modalities, how can we extract information of the different modalities to make sense of it for the models, and task of generation, which can be split to generation based on multimodality data and generation of multimodality data, and some auxiliary tasks like transfer learning and scaling. We can identify three types of multimodal solutions with LLMs. So you will know what is now in the field. First type is an orchestration, where LLM used as a controller, it receives the tasks, does planning, and decides which model we should use, and divides tasks, gets an information about the results to generate a response. And this type of approach can provide us a state-of-the-art model for each task, but there is no explicit link between modalities, and we can miss some data. Other approach is an end-to-end approach where we use multimodal data as in our training step and provide an architecture that can be trained in this paradigm. For example, like this one. And end-to-end approaches can provide very deep interaction between different modalities, but it's pretty complex. It requires a lot of data, and not everyone can train their own multimodal solution. And the most, I think, known across different solutions approach is projection layers, where we frozen LLM and frozen visual or audio or different types of encoders, I mean its weights, and train only projection layers, which usually consists of a few linear layers with some activations. And this approach can let us customize the connection between different modalities, but connection is pretty limited to the projection layers. And we can also miss some information. And next, I want to mention Retrieval-Augmented Generation. If someone not know don't know what it is, simply it's an approach where we can use external data and index it. Usually it's used with models to change our dimension to change our space to embedding space, and there we can semantically or even with different approaches retrieve relevant documents and provide it to the large language model to give them more information for the model without additional training, and it's a very famous approach. And why we want to use it? Because Retrieval-Augmented Generation focuses on the ability to read information, and we wanted to increase the interpretability and adaptability of the system we are building. So our main idea was to create a cross-modality retrieval system where we need three main components: general representation model to generate a semantic vector. For example, if we work with three modalities, it should be trimodal embedding. Retriever that can find our documents in vectorized space, and the language model to generate a response. And we refer to the Plato concept of recollection. He believes that all learning is kind of recollection of what we already know. So we wanted to recollect our data from the database as is, and we called our model approach MINO. For our experiments, we took all the English Wikipedia because it's pretty diversity. It has a lot of diversity, it has a big size, and there are natural paragraphs that we can parse to chunks in our database. And firstly, we aimed for an erudition subcategory. When we started to build our solution, we worked on an AI journey contest where this nomination was. And we choose for a general representation model one piece I already mentioned, and because it was a pretty good solution. There is not a lot of solutions for three-modal embeddings, and it was of a size 4 billion parameters, which was fine for us. We worked on V100 GPU on the start. But one-piece embeddings was pretty big, and we needed to change their dimensionally. We choose a principal component analysis algorithm to do it, and empirically we tried 100 principal components, tried more than 300, but decided that it's fine. And previously, our previous experiments showed that 300 principal components will be enough for a lot of solutions. For the search engine, we choose Annoy library provided by Spotify. It's pretty simple and based on clear algorithm of approximate nearest neighbors. But for our first experiments shown that model answers sometimes a lot of hallucinated answers, and this we investigated why and decided to add additional component recognition with additional auxiliary models to create a short text description of image by small model, or if we decide that there is a speech, we can use speech to text model additionally. And we need to re-rank our results of the retriever, and to use this, we choose an additional light text encoder. So our concept looks like this. Text data goes straight to the large language model, and image or audio data goes through general representation model to retrieve some data in knowledge source, and also go through additional small models to re-rank our results and choose the best topics to provide to LLM. And shortly details about what we choose. We choose BLIP as a lightweight image captioning model. Audio spectrogram transformer tuned on audio set, which had hierarchy because of ontology. And if the class of audio spectrogram transformer was speech, we decided to use Whisper Medium because it's not our main theme of speech recognition. And there we combine it by cosine similarity after the MPNet base. Short look of the system with models. For example, there is Mistral as a language model. An example of processing, for example, user image, it goes through recognizer and trimodal embedder, and we provide system instruction, results of these systems I mentioned, and user query to the full prompt of LLM to get a solution. We also gathered a very small data set in the competition based on the games, what, where, when, with 3 modalities at each time, up to 10 dialogues, approximately 5 in one. And for evaluation here, we tried BERT score to get a semantic evaluation of the meaning. And we build a prompt that persuades the model to believe that there is additional data, because model without additional training cannot see or hear something. So after this prompt, we amplified our best score more. And a small experiment of fine-tuning where we trained adapter, and it showed us that we can also adapt our models to answer in a paradigm of that concept of seeing on hearing things. For benchmarks, we used tiny LLM evaluation. It's based on a multimodality arena, but it's short. It's of 2,000 questions with different topics, and the core idea was to evaluate through other models with judgments that can correctly decide if the response right or not. And there is results of our first evaluation. We tried with Mistral models, and firstly we were worse than Lava models, almost in all categories except visual knowledge acquisition. But then we adapt our prompt, as I told you, and used newer versions of Mistral. And also we tried Fit3 model, which were trained on a more clear text, as authors says. And here we get interesting results. We beat even a huge model of a lot of parameters, like BART, now known as Gemini, with at least visual common sense and object hallucination. And it was one of our goals, because we wanted to create interpretable and adaptable system. Here is a diagram. If you want to look, our solutions is bold, and others are dotted. You can see visual common sense and object hallucination here. Also, small details, we additionally tried bench development set. There is a lot of interesting things in evaluation, like circular evaluation to see on the model consistency. And there is not that great results, but you can see on Mistral-based models, like model trained with projection layers, and our model, it is comparable. So our models provide not that much consistency, but you can see that we do not require a training of a model for a visual topic, but still get comparable results. So in conclusion, we demonstrate an algorithm that can be used without additional training and provide pretty good skills. And if you gather more data, you can even fine-tune models to answer better in this paradigm. And most of all, evaluation showed that in interpretability and adaptability, our system can be very great because of the hallucination and visual common sense topics. For future work, we want to focus more on comprehensive ablation studies and adding additional modalities and improving retrieval algorithm for better understanding. Thank you for your attention. The context of me and one of my colleagues.
Thank you, Roman. Do we have questions from the audience? Yes, please.
Yes, Roman, thank you for your talk. I've got a question. You mentioned that your multimodal model is like capable of visual and audio part, and you've shown us visual metrics like description of image and so on, but haven't you shown us like our audio metrics like word error rate and so on, like audio description, different things for this?
Okay, thank you for your question. The main problem is that provided benchmarks called multimodal, but they usually do not contain even audio data. But we wanted to test solutions that requires model to use few modalities at a time, and there is not good benchmarks for an audio, but we tried it on our simple benchmark or in AI journey contest. And here it was model was pretty good in our evaluation for this small benchmark with questions from 3 modalities. And we stopped on this and then just evaluated on 2 model benchmarks.
Okay, thank you.
Yes, thank you very much. So basically, when you have a number of modalities, you have 2 options. So one option is to embed everything into a single space. Another option is to embed it into different spaces and then combine. So from your point of view, what kind of approach is better and in which scenarios?
I think if you have a lot of resources, you can use one space or even train a model that can train a model from scratch to work with one space for a lot of modalities. But if you are restricted in resources like us, you probably want to find a solution to combine results from different spaces, because usually you can use models with less parameters for one modality and provide good results. And then you need a good algorithm to combine it. So in our solution, we tried to combine end-to-end solution in trimodal embedder and solution of orchestration model in our whole scheme.
Okay, I see. Thank you.
Thank you for your presentation. Do you have any applications for your model already, or maybe plan to do so?
We have a Telegram bot to try, and in terms of industrial applications, it's on a plan. My colleague now works on image part and image search engine. Maybe you can meet him later, Mikhail. And also, we worked a lot of different retrieval experiments with textual modality, and now on a way to combine it with other modalities. Thank you for the question.
You've mentioned that you plan to incorporate additional modalities in the future. So what are they? And as you already mentioned that the current benchmarks you use, they lack in some modalities, and it's difficult to test them, the performance of the system. So what you plan to do with benchmarking of this future system?
Thank you for your question. It's a very good question. Firstly, we want to gather some data sets. Now there is a lot of new solutions with thinking models, with reasoning models that can help us to create half synthetic data sets. And we want to try such modalities as graphs, formulas, and more technical things to create a solution, for example, as an artificial seminarist for helping with math subjects and etc.
Thanks.
Maybe one more short question, because at some point you show reg, but I missed. Did you really use reg?
Yes, I can show you it once more. Here is a retriever from trimodal space of whole Wikipedia English, and also we use a rerank of these retriever results with embeddings with textual embeddings from captions.
Okay.
Since there seems to be no questions from the audience, allow me one question from me. Could you please say that more details, share more details on the formula modality you said? You mentioned that you are planning to do something with formula modality. What is the features of this modality?
You mean what is
in comparison to specific, say, I don't know, the images?
Okay, I think it's a complicated modality because it combines some write-in symbols. So it's a combination of OCR, of technical details, and specific structures and symbols for formulas. So it's not can be simply resolved with OCR and just vision modality. So we define it as a new modality.
Okay, thank you. And you said that you're thinking of some neural seminarist or something. Do you think it will be enough from this, how we said, from this system to understand formulas and vision, and that's it?
I cannot provide an answer now because we need to gather more data and experiments, but we want to create this solution because it seems very interesting to help students with some, for example, they can take a photo and ask a model to help with a formula, to help with a graphic, and even it's handwritten. So it's our, I think, big goal, but for now, yes, it's a very hard task.
Okay, thank you.